It's just like she just like shut your stop the contact on that. So it's just,
Okay, this won't take very long. There's some history that I'll be able to tell you a little bit. It's always nice to have some history behind some of these individuals that are up here to kind of personalize it. Because sometimes you just say person's name, what they did, but you don't have any connection to what they have done or what their life was like. That's a nice thing that I try to do. I don't do the best job of it, but where I can get books, not related just to chemistry concepts, but the people involved with that is important. So when you guys did your questions, 1 through 4, there were some questions based upon different individuals. And one of the questions that had to deal with finding the method for measuring relative atomic mass, it was Stanisleo Cannizzaro. Okay? He did that 1860. They had a convention, right? They talked about this convention. They had chemists come from all over the place, mostly Europe, but probably United States, some different places, where they had labs, and they were doing experimentation in chemistry and physics. And what they needed is a way to connect the information in the lab so that they were all synced with the same information or same weights. So that they would look at data, because science is really data-driven. Okay, the data is not going to lie unless you, sometimes it will if you will change it a little bit. There are scientists known to change data to fit their thoughts. That's a bad deal when scientists do that. Because they say, well, it should have done this. I'm just going to fix this a little bit. And there was a scientist in, Soviet Union. They were all trying to come up with elements, man-made elements on the periodic table because they found a method in which to do that. Seborgium, he was the first one, Seborg, and he came up with the method to put these elements together in the lab. They just didn't last very long. So these Russian scientists said, we're going to go ahead and do it. And then they got this data, and then when they looked at data, they said, this doesn't make any sense. So they were credited of finding a new element, and then they were discredited because the data was changed around and it wasn't right. So,
would you get money if you found a new element?
Sure.
Like millions?
I don't know how much, but you bet you would be in the community, science community. That would probably be. You got the Nobel Peace Prize. You got the Nobel Prize in a lot of different literature, and you got it in science, and chemistry, for example, and physics. I think they get probably that foundation. Probably there's like $1 million or $2 million and those type of things. Okay, but he came up with a way to. He's an Italian chemist. Came up with a way that everybody agreed upon. And they said, "Yep, we're going to do that." Not too long after that, Dmitri Mendeleev. You read about him, right?
Yeah.
Okay. Mendeleev. I've used to pronounce it Mendeleev, but I think it's Mendeleev. And he was a Russian chemist. He was a professor at a university, I think it's Leningrad. His history was, he was, like 12, he was the youngest of like 12 or 13 or 14 kids. And his family ran a glass kind of factory, a glass company. I don't know exactly what they did, but they owned it. His dad passed away when he was really young. His mom was a go-getter, and she ran the company. But I think they had a fire or something happened where it destroyed a lot of the factory, and they couldn't continue on. And so she knew that he was pretty, really smart. She could just tell. Really smart, really gifted. And she made a trek from where they were at in eastern Russia to the west, Leningrad, and it took them like 2 or 3 months to get there. And in the process, traveling, getting worn down, she got sick. And just within a few years of after moving to Leningrad, she passed away. But before that point in time, she got him into the university, and he became, a professor, really, really smart, she really pushed him. They say really pushed him hard, in school. And if you guys think you're getting pushed by your parents to get good grades, you probably have no clue what pushing is, because she did it at the max. And because she knew that he had a tremendous amount of ability. So when your parents push you, and right now you might be getting pushed to get good grades, or do well in this activity, or do your best, and you kind of resent that, I think in the future you probably won't. It'll probably be something that you thank them, maybe. Hopefully you thank them for pushing you. Okay? And getting the most out of what your abilities are. And that's all we ask parents, is just do your best, try your hardest. You do that. Now sometimes we realize you're not doing that, and that's why we have a little bit of, we want to make sure that you're getting the best out of your abilities. Okay? So you can go and do what you want in the future, whatever that might be. So that's what Dmitri's mom did. Okay? And in 1869, he put together the first organized table of the elements. And we know it as the periodic table. Was the first to publish the periodic table and place it in a textbook. So textbooks were big back then, publishing those. They were much more work that put into them, a lot of new ideas that came out. Textbooks nowadays, there's probably not as much information, because at that point there was just a lot of new information each year that was really, really growing in the areas of physics and chemistry. He decided he was going to organize this periodic table, and it was kind of a funny thing, is that folklore has it that he did this in one day. He developed the periodic table and organized it in one day. Okay, that was probably a very productive day. Wouldn't you think?
They must have longer days back then.
No. Well, what he was doing, like everything, sometimes you've got the information, you're trying to organize it in your head, kind of how it goes. But he had index cards. And on each index card, he put information about the atomic weight. Like Cannizzaro said, here's the atomic weight. So he put those out on the 60 elements that were known at that time. He also put some information about their melting point, their boiling point, looked at how they combine with other elements, what their chemical characteristics are like, were they very reactive, non-reactive, those type of things. Had a lot of wealth of information on the index cards. And he laid out all the index cards out on a table, kitchen table. And he was trying to organize it, how does this work, and this, just trying to see how he could organize it to where it made a lot of sense. Well, then he took a nap. Naps are good, because he took a nap, and then they say that after he got up from that nap, he went, laid it all out. Within a short period of time, he had laid out the periodic table. Now, our periodic table has 30 more elements than his does, because we have 90 naturally occurring elements. Okay, even some of the index cards, they said, had coffee stains on it, because they had a coffee cup, had a coffee stain on the index cards. All right, so this is all kind of folklore, and how much of it's true, I don't know, but that's kind of what's come down, is that he kind of set that up one morning, and came up with the periodic table, published it, and now we're using it. Okay? So, you never know. We get up in the morning, not that you're going to organize the periodic table, it's already been done, but there could be some fantastic things you're going to do that day, and you just never know. Okay? Don't take a nap in class, though. All right? Don't take a nap. Have you ever done that, where you're studying, and then you go to sleep, and then you are dreaming about what you studied? No,
I
you
had
never
the
do?
weirdest dream last night.
Oh, no.
Don't want to do it.
It was weird. There
Okay.
were lions swimming underwater.
There were what?
There were lions swimming underwater. I was riding a hippo and they were biting my toes. And I had to climb a concrete wall to get my sister. And once I got my sister, I left her there for the rhinoceros to go through her foot. Like stick its horn through her foot. And we found her sleeping on our trampoline the next day.
Okay.
It was the weirdest dream.
Okay, we're not going to go on there. Okay? So, everybody get that? Alright, so what he did is he said, we're going to set up this periodic table and we're going to make sure as we go across a period that the weights increase every element. And then as we go, also that repeating pattern to repeat, we want to look at similar physical and chemical characteristics going down a group. So when you think about the something that's periodic, the calendar. Okay, the calendar is periodic. 7 days in a week. Every 8th day repeats. Okay, so Sunday's on the 1st. We know that the next Sunday's on the 8th. Next Sunday's on the 15th. We always repeat by 7. Okay, on a calendar. So periods in a day. Period 1 always starts at 8:12. If you're not there, you're tardy. Okay? Then period 2, it starts at what, 9:00? Is it 9 o'clock, 9:01? 9:03? Okay? And so we know that during the day we have periods 1 through 8 and they repeat themselves every day. Okay? So what he said is you're going to go across on the periodic table, but you're not going to continue to go across in a row. What you're going to do is you're going to find out you're going to have a pattern that repeats itself to where you have the similar physical and chemical characteristics that will line up in a family. And that's how he developed the periodic table. If you would turn to page 134 in your book, his periodic table is a little bit different than ours. As you can see, it's Russian. And he has hydrogen 1, and then he has lithium to the left of it. Where on our periodic table, I guess that would be consistent with our periodic table, but lithium and sodium are going across, where on our periodic table, lithium, sodium, potassium, rubidium, cesium go down. So, if that makes sense, his periods are going up and down vertically, and then horizontally would be their groups. So you can kind of look at the groups and kind of see how fluorine, chlorine, bromine, iodine, they're going across the row, where in ours they go up and down. So if you turn it sideways like that, it'll be the same as ours, or real similar to ours. Okay? So that's that published periodic table, kind of looking at weights. And you notice their weights only go the nearest, for most part, they only go the nearest, one spot. What's TO? Thallium. Okay? So, this is the weights they came up with this time. Of course, we've got better ways in which to measure atomic weights. And they probably have changed a little bit, not a lot, but changed a little bit. Do you remember there was 3 elements that were discovered within a short period of time after he published the first periodic table? Remember what they were? Scandium, gallium, and germanium. Good, you guys did your homework. Okay? There's a whole family that hadn't been discovered up to this point in time either. Not till later, not till early 1900s. The noble gases. The reason why, they're not in any compounds, so they can't really isolate them out. Right? Last slide. Okay, he had a problem with the periodic table, and he didn't know why it was turning out to be that way, and it would be like tellurium and iodine. If he went according to their weights, and only strictly their weights and not their properties, iodine would come before tellurium. In our periodic table, that's not the case. If you look on page 141, 140 or 141, turn over to those pages. You'll notice iodine, its weight's 126.9, or I rounded up to 127. And tellurium is 127.6, I just rounded up to 128. Do you realize weight does not increase between those two, but actually goes down?
What the
Okay, so the weight went down. It went from, when you go across the period, it usually increases by weight, but tellurium is 127.6 and iodine is 126.9. So the weights actually went down when they looked at the relative weight. Can you see some other cases where on the periodic table when you look, let's don't go down in the F's, let's keep in the D group and the P group. Is there any other cases where when you go from one element to the X it doesn't increase in weight? Yes?
Let's see. Oh, I lost it. Nope, found it. The DB and this one.
What element number?
Oh, 106 and 107.
Okay. 106, 107, we're getting down there. So it goes from 266 to 264. What's another one? Alec?
There's one that says the same, but there is what was it? PU and AM. It's 244 and it's 243.
Yep. Okay. Can you think of some others? Yes.
112 and 113.
Yep. You guys are getting down there. Let's see if you can figure some common ones that are up above. Yeah.
Thorium and protactin.
Thorium and what element numbers?
90, 91.
Okay. 90, 91 goes from 250 through 232 to 231. Yep. Yep. Yeah, argon and potassium is a good one because it goes from 39.948 and it goes down to 39.01.
Well,
And then there's one that you guys probably would be able to see real easy if you looked up, and it's cobalt to nickel, 58.9 to 58.7. So he felt that he's going to group according to properties more than increasing in weight. So for the most part, he always said it should increase going across the period and increasing down a group. But there were some instances that he'd come to two elements that didn't fit that way. Tellurium does not have the same properties as iodine does, and so iodine fits better in the halogens because it has similar characteristics to the halogens. And tellurium fit better in its group with selenium and sulfur and oxygen. Okay, and so he decided, I am only going to look at chemical and physical characteristics when I group them, even if my pattern doesn't work. Yeah.
Did they name Mendeleev over him?
Yep, Mendeleevium is named after Dmitri Mendeleev. Yep.
only by chemical property.
Well, if he had his choice, which one that would be more important? It's more important to go by the characteristic than the weight, where it's at on the periodic table. Okay? Now, the last one I'm going to talk about, Henry Moseley. Henry Moseley was an English physicist that came up with a way. You guys remember what he discovered?
Oh, I saw the question I can tell you.
Periodic law.
Okay, but according to periodic law is really, this Mendeleev did that as well, but his weights didn't match up very good. But what did Moseley do the periodic table as? Atomic number. Because Moseley found a way to X-ray the atom, or group of atoms, and by X-raying it, he was able to determine that the charge of each atom when you work across the periodic table increases by a charge of 1. And we know that is the what? What is that? Protons in the nucleus. Always increase by 1. So potassium to calcium, it goes up by a charge of 1. Okay? And so he was able to give those numbers, those atomic numbers, and now they make sense because iodine, or tellurium is element 52 and iodine is 53. Well, now they go in order. Okay? There's no problem with that. Now, being today's Veterans Day, Henry Moseley did this when he was about 19 years old. Came up with a method to find the number of protons in each atom, able to connect it to the periodic table, and realize this is why the periodic table is set up this way. It's by atomic number better than mass, because mass doesn't work out all the time. He decided he was going to join the Army. He joined the Army, and he got killed in a battle. And the science community there in England was very distraught. They really, this individual could have done a lot, and he'd already done a lot at age 19. Okay? And so if somebody, when you think about Veterans Day, there's a lot of individuals that never did come back from war, and we're able to sit in a classroom and have freedom of a lot of different areas. And it's because of those individuals that go, and they don't have to do that, and they do it. So, so think about that. Today's Veterans Day. Probably need to give a lot more attention to it than we do, but it's something that's important. They need to be celebrated, and for what they've done. So, what I'm going to have you do now, the band students can go.
Carter, what time did we go?
I think 45.